All right, we're now going to get started with the second video for Unit 5, Land and Water Use. We're going to talk about human alteration of water availability. So humans around the world have learned to live with variations in water availability. Every single biome, every environment that humans live in does not always have the same amount of water available to those humans that settle there. So humans have derived several different methods to distribute water to help them with whatever it is that they're trying to do in a particular location. So they have done things like build levees and dikes, dams, aqueducts, and they go through some processes to get potable water what may not be available, such as distillation and reverse osmosis. So in the previous video, we talked about how humans have historically, for thousands of years, settled along the banks of bodies of water, and in particular, they have settled along the banks of rivers, along large river banks. And we know that most rivers periodically overflow their banks and flood the surrounding land. And this is just a normal part of the life of a river. There's periodic seasonal flooding that happens. So this water usually deposits nutrient-rich sediments on the surrounding land and results in a particularly fertile floodplain, which is one of the reasons that humans have chosen rivers as ideal locations to settle, one of several reasons that we talked about in the previous video, like I mentioned. So throughout history, humans have taken advantage of the fertile lands in the floodplains for agriculture. Recently, however, humans have started to maybe become annoyed with all the flooding that happens around a river all the time. So they have sought ways to prevent the flooding. So the floodplain land could be developed for residential and commercial use. So as human populations grow and civilizations grow, people want more houses, they want more stores, they want more things, not just a bunch of farmland. And our farming methods have become much more efficient and centralized and industrialized. Now, one of the ways that humans have derived to prevent or to reduce the amount of seasonal flooding that naturally occurs in rivers is to construct structures called levees. So levees are essentially in large riverbanks. They're built up on each side of the river, and they're there primarily in order to prevent flooding. Levees are built primarily to prevent flooding. Now, there are several challenges that can arise when levees are constructed. And as we've already talked about a little bit, this seasonal flooding, this periodic flooding that every major river goes through, brings nutrient-rich sediments to the floodplain. Well, if you prevent that flooding from happening over a long period of time, you end up reducing the fertility of the surrounding floodplains because they're not getting that continual sort of periodic input of nutrients into the surrounding floodplain. What also can happen is the sediments do not leave the river and they are carried further downstream. So there is sort of a net movement of sediments towards the ocean as things move down the stream, and because you're missing these sediments that are being deposited all along the floodplain. What can also happen is that sediments can accumulate in the river channel and they can raise the water level. I actually saw this myself. The first time I ever went to New Orleans, I was 16 years old, and I remember we went from the city, we went to go look at the Mississippi River. And we went to the Mississippi River, and on both sides are these levees, and I walked up to the top of one of these levees. It was an area, a park or something, where you could go right up to the river. I walked up to the top of the levee, and I looked at the Mississippi River, and then I turned around and I looked at the city of New Orleans, and I realized that the top of the river was at least 20 feet higher than the city of New Orleans. So the water level of the river was actually higher than the city. I had to walk up to the river. It was very odd, and I could tell that there was something wrong with that. It seemed very unnatural. And lo and behold, several years later, those levees did fail in New Orleans and with Hurricane Katrina and cause major damage. So levees also force floodwater downstream where it could result in more severe flooding. So if all this you have all this water input coming from snowmelt or rainfall, seasonal rainfall that normally would flood all along the course of the river, if it is continually not allowed to flood, then you have this buildup of water that would normally have breached the riverbanks, flooded the floodplain, and maybe percolated down into the water. But instead, it's all just channeled all the way downstream until eventually you could have, if you have a flood event further downstream, you have severe flooding because there's so much water that has been forced downstream when it would have possibly further upstream, if it had been allowed to flood, it would have flooded into the floodplain and then percolated down and left the river channel. And in addition, what happens is when we build levees and you take away that seasonal flooding that occurs, you actually get more development in the floodplain because people don't have to worry about flooding so often. At least they think they don't. And they really don't for most of the time. Now, as I already alluded to, that when floodwaters can become too high, you can have too much water and the levees can actually collapse, or water could possibly flow over the top of the levees, and both of these events can result in massive flooding. Famously, like I already mentioned, in 2005, Hurricane Katrina had almost a direct hit on New Orleans and caused levees to break that were going right through the center of the city, essentially. And the overall death toll from the hurricane was about 1,800 people died, and it caused more than $80 billion worth of damage. So it was incredibly destructive. And part of the reason was blamed on these levees that were just holding back this water, and it was just waiting for that perfect storm to come in and cause this massive damage and massive loss of life. And here's another picture right here of a levee that's breaching a dam in St. Louis. This is a Mississippi River as well in 2008. Another thing that people do to alter the water availability and water flow is they build dikes. So dikes are similar structures to levees, but instead of dealing with rivers, they are dealing with ocean water. And so dikes are built to prevent the ocean waters from flooding adjacent land. Now, so dike is a structure built to prevent ocean waters from flooding adjacent land. So now functionally, dikes are similar to levees, like I said, but they do seem to be a little bit more sustainable, at least if they're done correctly. The dikes are very common in Northern Europe. Famously, the Netherlands has a whole entire system of dikes that has expanded their land. They've basically reclaimed land from the ocean to have their country. And they've been using dikes in one form or another for 2,000 years, incredibly long time. And about 27% of Netherlands, the entire country, is below sea level. So they use a system of dikes and pumps to move any ocean water that intrudes past the dikes and pump it back into the ocean. And Netherlands, Holland, is famous for their windmills. And one of the primary functions of the windmills historically has been to run these pumps that's pumping the water out of back into the ocean from the land that it has intruded into. Like I alluded to a second ago, dikes can be less problematic than levees because the sediment buildup in the ocean is not as big of an issue. So you don't really have a raising of the water levels in the ocean because there's sediment that they deposit. It's a little bit different than a seasonal flooding that happens with floodplains and rivers. And you can see this, they've been sustainable in a place like the Netherlands for 2,000 years. That's pretty substantial and significant. And they have worked with their environment to try to maintain their country as best they can. Maintain the land of their country as best they can. Now, what is challenging the dikes in the Netherlands and in a lot of coastal areas around the world is that climate change is raising the sea levels, and this does present a challenge for the land that's protected by the dikes. But the Netherlands obviously is not going to go down without a fight. They are continuing to improve on their dike building technology. And so here I have a couple of pictures of dikes from the Netherlands. So here's the ocean right here. There's a dike right there. And you can see that this house and their farmland right here is well below the sea level, well below the ocean. Here's another dike going through the countryside. I think I've seen a picture of the same dike where it's just filled with water on the left side of this picture. Here's another dike. There's the ocean out there again. And you can see all these houses and development. You have the ocean here. There's the the dike is built up, and then you come down, and these houses are really at or below sea level on the other side of the dike. That's how they've dealt with their country for thousands of years. Another famous alteration of water that humans undertake is the construction of dams. This to control the flow of water. There are a lot of different reasons that humans do this, but a dam is a barrier that runs across a river or stream. So it runs across a river or stream, and it controls the flow of water. Now, when a dam is built, the river or stream on the upstream side of the dam essentially fills up and becomes a lake. And this kind of lake is called a reservoir. It's a water body that's created by damming a river. and some of these are massive in size. So dams can hold water for a variety of purposes. People do this for a variety of purposes. One is water consumption. So you have reservoirs that are primarily there for humans to drink the water. You have generation of electricity, hydroelectric power. Many are built for flood control. Some are built for recreation. There are reservoirs that are created with the primary purpose, actually, of providing a big lake for people to go and water ski on and swim in and that sort of thing. And another purpose sometimes is that, and sometimes a lot of these, sometimes these purposes kind of go together, is residential development. So there are some reservoirs that are constructed, and one of the reasons, maybe not the primary reason all the time, but one of the reasons could be to develop houses or condos or hotels or something along the shores of the reservoir that's developed. The pictures right here show one of the most famous, largest dams in the world. This is the Hoover Dam. This picture, I think, is about 1935. It was constructed, so this is the upstream side of the dam, and this is when the dam is filled, and down here you can see the water is beginning to fill up and form what is now Lake Mead, this large reservoir upstream from Hoover Dam. And these towers right here are actually the intakes for the hydroelectric generators that are run by this dam. It is a hydroelectric dam in part. And this right here, this picture right here, is a picture from the same side, although maybe on the other side of the ravine. Looking down, you can see this is a more modern, present-day picture with the Hoover Dam there. And here's another. We'll look at the next slide. It's got another picture of it as well. And so here's another picture of Hoover Dam from downstream, looking upstream, looking up into Lake Mead. One of the tallest dams in the world, over 600 feet tall, I believe. So here we have the dam facts. Okay, so there's 845,000 dams worldwide, about 84,000, about 10% of those are in the United States. Within the United States, the Missouri River Reservoir System is the largest system of dams on any one river. The reservoir system holds about 90 trillion liters, about 24 trillion gallons. In the U.S., only about 3% of the dams that we build are hydroelectric, about 18% are flood control, about 38% are recreation, and the vast majority of the rest of those are reservoirs built for human consumption, for drinking water. The largest dam in the world is the Three Gorges Dam on the Yangtze River in China. And I think that's 2.3, not 2E. I think that should be, 2.3. Trying to draw a 3 here. It's not working very well. 2.3 kilometers wide and about 185 meters tall. So that is the largest dam in the world. I got some pictures of that on the next page. So here's a picture of one picture of the Three Gorges Dam. I've got another picture on the next slide as well. Dams do provide substantial benefit to humans. They provide a tremendous amount of electricity. They can provide a tremendous amount of electricity, and electricity is a much cleaner, hydroelectric power is a much cleaner source of power than burning fossil fuels. There's very little in the way of carbon dioxide production from fossil fuels. They provide drinking water and other benefits that we mentioned. But there are tremendous and significant financial and societal and environmental costs. Now, a benefit, again, I've already mentioned, is that the electricity produced from a hydroelectric dam can replace fossil fuel. Reservoirs for drinking water can be very important. And the Three Gorges Dam, for example, has prevented flooding that over the last 100 years has killed more than 1 million people in China. Downstream in the Yangtze River, there's been major floods that have killed people, and these floods have been greatly reduced. Now, there are environmental costs to that as well. And upstream, however, when they built the Three Gorges Dam, it essentially eliminated 13 cities, 140 towns, and more than 1,300 villages, and displaced about 1.3 million people who had to move because their town was now underwater. It also, it seems to have been quite an environmental disaster potentially. A lot of threatened flora and fauna have really been harmed or damaged by the building of this dam. In particular, there's an animal called the baiji, which is the Chinese river dolphin, which is an extremely rare dolphin, and only lives in the Yangtze River. This and some other habitat destruction issues have caused the Chinese river dolphin to be essentially extinct. It has been declared extinct, but there have been some sightings of it recently, but really it's on the way out. And it is actually the first dolphin in history to have been driven to extinction by humans and it's been in this river, they estimate, for about 20 million years. Also, it turns out that the formation of this reservoir behind the Three Gorges Dam has resulted in landslides. So the water table has become saturated, and that has caused some landslides, an unexpected consequence, and even dam quakes. There's some research that shows that large reservoirs can actually cause minor earthquakes as well. So there are some drawbacks to this dam building that can offset some of the benefits that you get. Here's another picture of the Three Gorges Dam. And this is the reservoir formed behind the dam and the Yangtze River passing through. And over here is a picture of the baiji, the Chinese river dolphin. It's a small dolphin about 6 to 8 feet long, freshwater, the only freshwater dolphin species, and effectively extinct now. Okay, one of the most common environmental problems associated with dams is that there's an interruption of the natural flow of water. And this really disrupts the river ecosystem. There are many organisms that are adapted to this natural flow. They're adapted to the natural flow of the river itself, and also to the seasonal and periodic flooding that occurs. So they can be it has extremely adverse effects because of the dam construction. This is especially and famously notable with certain fish species such as salmon that migrate up and down rivers in order to breed. So for these fish, a dam is just simply an insurmountable barrier, and it completely cuts off their life cycle and their ability to reproduce, and can completely cause a complete and total population crash within the population of that river. So it can lead to total loss of this fish from the dam river, and a loss of salmon can have a cascading effect on other organisms that depend on them. Salmon runs they're really a famous spectacle that you often have, probably many of you have seen before on Animal Planet or some other documentary. But basically, it's bringing a tremendous amount of biomass, a tremendous amount of food up into a river system, and there are many other species that depend on this food to come in annually as the major source of food for the entire year. Things like bears and birds feed on these salmon. Bears famously. Also, a lot of other animals that you may not necessarily think of, like wolves, seals, dolphins, otters, etc. Many raccoons, many animals feed on these salmon that come in. Now, to alleviate this problem of the dams completely cutting off the reproductive cycle of the salmon, one solution that has been shown to be fairly effective is the construction of fish ladders that can be added to some dams. And so down here you can see there's a fish ladder that's been constructed for salmon and other fish that move up and down the stream to get past this dam that's over here in the lower left. So basically the idea is that the fish are swimming upstream, and they enter into, and they're actually attracted by the flow of water up into this fish ladder right here, and they basically just work their way up. It's like a staircase that walks themselves up to the point where they can pass over the dam. The next slide has a couple more pictures of fish ladders. So again, a fish ladder is a stair-like structure. It allows migrating fish to get around a dam. So the migrating fish swim up the fish ladder because they're naturally, salmon are very strong swimmers. It is part of their life cycle to swim upstream. So they're very strong swimmers. They naturally have the ability to jump up streams, up small waterfalls and small barriers, up and over. But the dam is just too large of a barrier. Here's a fish ladder. Here's a dam right here, and the fish ladder is shown right here, coming up and around this way, and it probably loops in over here somewhere. The fish are coming in. The fish are coming in and swimming up the fish ladder. Over here on the right side, you have a cross section of fish ladder. So the basic idea is that the fish have the ability to jump up these small little barriers and work their way up. They turn around, and eventually they are able to get up and over the dam. And it has proven to be fairly successful for these species of fish. Now, it turns out that these dams that have been built to prevent seasonal flooding, which is a large percentage of the dams that have been built in the United States, and in all dams in general, but what they end up doing is they prevent a natural disturbance that was a normal, natural part of a river ecosystem. Now, so obviously this can be problematic because the cyclical seasonal flooding favors many plants and animals that are specifically adapted to and highly dependent upon this disturbance. This is something that they have been living with for thousands or hundreds of thousands or millions of years, and so they have adapted their life histories to work with, they've co-adapted or co-evolved to live in these systems. And when we build these dams, we kind of mess up their life cycle. And some of these species are also very rare. And this has, the building of these dams has really had negative effects on these species. It also turns out that building dams for flood prevention may do a good job locally in areas near or around the dam, but they can actually, as we've talked about a little bit already, they can result in more severe flooding further downstream, where because the water is not allowed to flood normally up and down the length of the river, that water is just funneled all the way down, and further downstream you can have major severe floods because there's so much more water being delivered, ultimately because of the flood prevention nature of these dams. So there's been a movement recently, and this is a science-based movement by the managers of some of these dams, where they have experimented with releasing large amounts of water from the reservoirs. We've done this with hydroelectric dams and these flood prevention dams in order to simulate seasonal flooding. So there's these periodic water releases where they release a large amount of water, and the water is allowed to go down and flood the floodplain. And this has had very promising results. There has in areas where this management practice has been enacted, there have been recoveries of these rare species that depend on the seasonal flooding. In addition, nearly 1,300 U.S. dams have been removed that were primarily these dams that were built for flood prevention, but some of these are even hydroelectric dams or other dams. And it has been shown that the habitats, when this happens, the habitats rebound very quickly. It turns out that these riparian habitats are quite resilient. These riparian means habitats around the edges of rivers. And it shows that these habitats are quite resilient and they can quickly rebound. They're probably resilient because they have co-evolved to deal with disturbance for hundreds of thousands or millions of years, and because of that, they can rebound when there is a disturbance, and so they can recover. So there are some spectacular videos, I'll show them in class, of them blowing up or deconstructing these dams and talking about how it has affected the river ecology after they remove the dams. I'll show those in class. Okay, another way that humans alter the water availability in any given location is through the building of aqueducts. So oftentimes humans need to move water from one location to another, and this is what aqueducts are for. So aqueducts are canals or ditches or pipes that are used to carry water from one location to another, and they've been used for thousands of years. The first large-scale aqueducts were used in the 7th century in Greece, even before Rome. Rome is famous for its aqueducts, but they have been in use for hundreds of years before the Roman Empire was established. These are often used in arid regions that have little available surface or groundwater. Around where we are, New York City, at least, they get their water through a 200-kilometer aquifer called the aqueduct, through a 200-kilometer long aqueduct called the Catskill Aqueduct that brings water from the Catskill Mountains to New York City. New York City famously has really good water, somewhat surprisingly, actually. The Colorado River Aqueduct is another large-scale example that brings water from the Colorado River all the way to Los Angeles. It's about a 400-kilometer long aqueduct. And so here's a picture of the Colorado River Aqueduct that is carrying water through very arid regions in Southern California and bringing it to Los Angeles. Now, aqueducts, keep trying to say aquifer. Aqueducts come with costs and benefits. So they're very beneficial in the fact that they are bringing fresh, clean water to large urban areas, or people live in urban areas, and it's important for people to have good access to fresh, clean water. And so that is a tremendous benefit that aqueducts have. Now, they are very expensive to build. They can and often do disturb the natural habitat. And above ground aqueducts can cause some habitat fragmentation, which is a major problem for animals or plants and animals nowadays. Water depletion can also cause rivers to run dry, and this is one of the primary, I would say, or the most impactful negative impact is the depletion of water. The Colorado River is this incredible example of misuse of water. The Colorado River essentially runs dry by the end. And this is a river that has formed the Grand Canyon. Essentially, is like a tiny little trickle by the end of its flow. And the Rio Grande also forming a large portion of the border between the United States and Mexico has also been greatly depleted through the use of water diversion, in part through aqueducts. And there's also international impacts. So in 2016, India began a plan to divert water from 50 large rivers that flow from India into Bangladesh. And so these rivers are shared by two different countries. India stands to gain about 170 billion liters of water per year from this project. But what that means is Bangladesh stands to lose this river flow. And further downstream, also, the freshwater flow into estuaries may be reduced. And because of this, you can have ocean water intrusion into these estuaries because the pressure coming from the freshwater flowing out from the river into the estuary is going to be greatly reduced. And so this is obviously Bangladesh is not thrilled with this project. And so these are issues that come up with water diversion. This happens with dam building as well. There are disputes in the United States between for 40 years now at least. Georgia, Alabama, and Florida have had a dispute over water resources that they share, rivers that they share. Whereas Georgia wants to divert a bunch of water for drinking water for Atlanta, and Alabama and Florida are not happy with this because they're losing that water. So these are real issues that can cause internal state disputes or international disputes. Another example, a very famous and tragic example, in the 1950s, the Soviet Union diverted two rivers that were feeding the Aral Sea in Central Asia. The Aral Sea is in Kazakhstan and Uzbekistan. Now, at the time that this happened, Kazakhstan and Uzbekistan were part of the Soviet Union. It was all one large country. The Aral Sea, when this project began, the Aral Sea used to be the fourth largest freshwater lake in the entire world. But this diversion has dramatically reduced freshwater inputs into the Aral Sea, and the salinity of the remaining lake water increased because you had less water flowing in. And so as the water levels went down and down and down, but the substances dissolved in the lake, the salts dissolved in the lake, increased in concentration because the water volume decreased. Local fish populations were destroyed. Surface area to date has been reduced 60%, and the Aral Sea is now split into two different water bodies, the North and South Aral Sea. The exposed soil have dried up, and dust storms have eroded the soil that used to be the bottom of the lake. The reduced lake size has resulted also, the lake was so large that it affected the local climate, and water has a mitigating effect on climate. It tends to, if you have large bodies of water, they tend to cause the winters to be more mild and the summers also to be more mild, so less extreme. So now in this area they have hotter summers and colder winters because the buffer effect of the Aral Sea is no longer in play. And the South Aral Sea itself is predicted to be completely dry within about 10 years, so they may be lost completely. So here's a map. You can see the Aral Sea right now. This is as it looks right now. There's Kazakhstan here and Uzbekistan. There's Russia. All of these used to be part of the Soviet Union. After the Soviet Union broke up, these became their own independent countries. You can see this is the Aral Sea as it once looked. This is not an accurate map now, but even this is not how it looked in the beginning. So we'll look at the next picture. You can see some of the transition. So in this slide right here, you can see the transition from 1960 to 2014. So you see right here, there's the Aral Sea in 1960, one large, huge body of water, several islands throughout the Aral Sea, all fresh water. 1973, you can see the sort of darker beige areas where the water level or the shoreline is being reduced. And as you move through time, 73, 87, being reduced even more. 1999, further being reduced. Now we have right here, I believe we have the separation. There's the South Aral Sea, and here's the North Aral Sea. The North Aral Sea, now they have put dams in place to make sure that this part does not dry up completely, but the South Aral Sea, because of that, it's maybe a death sentence for the South Aral Sea right here, 2014. They are predicting that this portion will be dried up completely. So you can see it went from this very large freshwater lake, fourth largest in the world, down to just a remnant of what it used to be. All right, the last two things that we're going to look at are looking at what some water-poor countries will do in order to try to get fresh water. So some water-poor countries are able to obtain fresh water by removing salt from salt water. So there are some water-poor countries, and this is particularly true in the Middle East region, where you have some countries that are almost completely desert, but they have a large coastline. They have access to ocean water. They have access to salt water. So this process of removing the salt from salt water is called desalination. It's also known as desalinization. So salt water usually comes from the ocean, but it can also come from salty inland lakes. So many countries in the Middle East are in this category of a water-poor country, but with unlimited access to salt water. The Middle East produces about 50% of the world's desalinated water. And recent technological advances have greatly reduced the cost of desalination. However, it is still an energy-intensive process. It does require a lot of energy and a lot of resources. It's expensive. So the two primary desalination technologies, there's distillation and reverse osmosis. So the first technology is the older technology, distillation. This is a process of desalination where the water is boiled, and that takes a lot of energy in and of itself, and the resulting steam is captured and condensed to yield pure water. Okay, this is the process of distillation. It works. It's incredibly effective. As the water is converted into steam, the salt is left behind. Distillation, however, is energy intensive, requires a great deal of energy to boil and then condense the water. Very expensive monetarily and environmentally. So this is it's not a very cost-effective solution, but if you have no water, you must have water. Human beings must have water, and so it is worth it for these countries to do this, but it is not a very cost-effective solution. So seawater, so basic idea. So step one, seawater flows into the chamber. Heating elements boil the water. They're in boil the water, and this creates steam. Okay, the cool seawater, step 3 here, the cool seawater is condensed in the condensing coil, causes the steam to condense. And then you have, or the heating element down here, sorry, I'm not really showing this very well. Okay, so the salt water comes in, it collects on the bottom, it is boiled down here, steam collects, the cold salt water coming in functions not only as a delivery system of the salt water, but also to cool the steam that rises from this boiling water, and then the steam drips down onto this angle right here, the structure right here, to collect the water separated from the salt water, and then that flows out to be used for whatever purpose it's needed. Now, one of the environmental problems with distillation is that once the process is done, there is still some salt water left over. This is called brine. It's very, very salty water, much more salty than the ocean, and it's so salty it's somewhat of a environmental pollutant. It cannot be certainly cannot be dumped out onto terrestrial environments because the salt water is very damaging to organisms living in the terrestrial environment, and it can even damage locally organisms in the ocean if it's dumped back into the ocean because it is so salty. So this is an environmental problem with distillation, in addition to the great cost and energy needs to desalinate salt water. The other technique is a newer technique. This is called reverse osmosis. So this is a process of desalination where water is forced through a thin semi-permeable membrane at a high pressure. So basically, water passes through the membrane, but salt cannot. So you have a very, very tiny membrane because salt is very small. But reverse osmosis is more efficient and often less costly than distillation. But it still produces brine. There's still this extremely high salt content in brine that is left over, and this can cause environmental damage when returned to the environment, just like in standard distillation. So both of these do have some environmental costs and high monetary costs as well. Reverse osmosis is a little bit more promising, though it's a little less expensive because you don't have to heat the water. Boiling water takes a tremendous amount of energy. Here it's just a physical process where you're filtering out through very, very small permeable membrane. You're filtering out that salt. All right, so finally, all water management systems require very large investments to build, maintain, and repair. And many of these water-poor countries are developing countries. They don't have a lot of resources. They're not able to implement large-scale methods of water management because they just don't have the money to do so. About 15% of the world's population, that's 1.2 billion people, live in regions that have a scarcity of water. And so you can see on this map, looking at water resources, and you can see much of northern Africa and the Middle East and even India, which is very problematic. These are areas where you have a limit water. There's some water scarcity, and you look at some of the some other parts of the world that are particularly the well-developed countries, but not all the well-developed countries. They have a very good access to fresh water, but this is a world problem that especially it's the poorest countries that have the biggest issue. So that it's a problem facing humans as we move forward.